Hey there, everybody. Welcome back. It's good to see you guys again. I hope you guys are ready to dive into a new chapter. Today, we're starting chapter 5, which is on rational expressions. And we're going to start with just simplifying them for 5.1. We'll do 2 videos for this section. In the first one, we're going to talk about the domain for rational functions and domain violations or rational expressions. Let's go with rational expressions. Domain for rational expressions and domain violations. That doesn't look like a very good spelling of domain. D-O-M-A-I-N, domain. So maybe we should start with what a rational expression is. A rational expression has the word ratio in it. It's a fraction. It's expressions that have fractions. Specifically where the variable is in the denominator as well. So polynomials, we didn't have any variables in the denominator. Rational, there are problems that do though. They exist. And we will have some applications later on that show this. So things that rational expressions can be like 1 over x or 3x minus 1 over 3x plus 1. It can be, it can be crazy. We have something like 5x minus 2 over x squared plus 5x plus 6. These are all rational expressions. So when we say domain, the domain is the set of all values for which these expressions, or for which the expression is defined. Common words. What x's work? So the bottom isn't 0. Domain violation is something I call it, and that's not official math jargon. When I say violation and it's not really violating the domain because the domain can't include anywhere the bottom is 0. So for like 1 over x, if x equals 0, this is undefined. For 3x minus 1 over 3x plus 1, if 3x plus 1 equals 0, or x equals negative 1/3, this is undefined. And if we take a look at 5x minus 2 over x squared plus 5x plus 6, we want to see where x squared plus 5x equals, or plus 6 equals 0. That's at x plus 3, x plus 2 equals 0. So x plus 3 equals 0, or x plus 2 equals 0. X equals negative 3, or x equals negative 2. If x equals negative 3, negative 2, or negative 3, this expression is undefined. So when we actually when we're solving problems, if we solve problems and get something like this as an answer, we have to reject it. It's going to violate the domain. It doesn't fit in the domain. Okay. That's a quick description of domain. And let me put up a couple functions and let you figure out what the domain has to be, or what the domain can include. In fact, we're going to simplify these in a little while. (40 times x plus 7 over 36 times x plus 7. X cubed minus 8 over x minus 2. And let's go with something like y minus 5 over 2y squared minus 9y minus 5. Go ahead and try to figure out what values for x or y in the last one violate the domain, and then we'll do it together. Right, this, if we have 36 times x plus 7 equals 0, we violate it. So x plus 7 cannot equal 0. X cannot equal negative 7. For here, you will end up with x minus 2 equals 0. X cannot equal 2. And let's see, what does this factor into? Negative 10 and adds to negative 9. 2y squared minus 10y plus y minus 5. Do some grouping here. I got 2y plus 1 times y minus 5 equals 0. This one, you are going to get y equals negative 1/2. This one, you're going to get y equals 5. Those violate it. So if we were to write the domain, we could do it like this. The domain is negative infinity to negative 7 in union with negative 7 to infinity. This is how we shows that we are excluding the violations or the violators. That's A. Problem A. Problem B. Why don't you try to show the domains for problem B and problem C? I guess I didn't label them. A, B, and C. Pause it and try to show what the domain would be in interval notation. All right. So if you did, you should get negative infinity to 2 in union with 2 to infinity for B. And in C, we can't include negative 1/2 or 5. So we're going to go negative infinity to negative 1/2 in union with negative 1/2 to 5 in union with 5 to infinity. All right, that's it for domain. We will do more on this section in the next video. We're going to start simplifying. Peace.